myself Emma Zohan, roll number 21D76, and I am performing digital signal processing lab number 8 with the title of Moving Average Filter FIR Filter Fourier Transform Design Method. So in this lab, we will going to learn how to implement and analyzing moving average filter out and how to implement and analyze the finite impulse response filter Fourier transform design method. So first of all, we will perform it task number one in which we have to design filter, tell about what is filter, type of filter, time domain parameters for a filter and frequency domain parameters for a filter and role of row pass filter for filter designing. So first of all, we will discuss what are filters. Filter in signal processing are algorithms or define or devices used to modify or extract specific components from a signal. They can be used to remove noise, enhance certain frequencies, or perform other operations on audio, video, and other type of signals. Then the type of filters, there are 12 types of filter which are low pass filter, high pass filter, band pass filter, band stop filter, Butterworth filter, Chebyshev filter, elliptic filter, FIR filter, double I filter, and Kalman filter, median filter, and last one is adaptive filter. They are different in their uses. So first of all, we will tell about what is low pass filter. It allows signal with frequency lower than a certain cutoff frequency to pass through. While attenuating higher frequencies, high pass filter is used to pass the frequencies with higher frequencies which have higher frequencies and cutoff frequencies. Similarly, band pass filter is used allow signal within certain frequency range to pass through while attenuating frequencies outside this range. Band stop filter attenuate signal with a certain frequency rate while allowing frequency outside the range to pass through. Butterworth filter, a type of filter designed to have maximally flat frequency response in the pass band. Filter type of filter that achieve a steeper roll-off in the stop band than the Butterworth filter at the expense of ripple in the passband. Elliptic filter is used to combine the characteristic of Chebyshev and Butterworth filter, providing a steeper roll-off and less ripple in both passband and stop band. FIR filter, which is finite impulse response, is used where the output is a weight sum of past input samples with the coefficients of the sum being the impulse response of the filter. Double I filter, which is infinite impulse response, is the type where the output is with sum of past input and past output samples, allowing feedback in the system. Kalman filter are a recursive algorithm used for estimating the state of linear dynamic system from a series of noisy measurements. The second last one is median filter, which is a non-linear filter that replace each pixel value with the median value of the intensity in the neighborhood of that pixel. And last one is adaptive filter, a filter that automatically adjusts its parameter based on the input signal, typically used for noise cancellation or equalization. Now we will discuss about the time domain parameters for filters, which are impulse response, step response, transition response, and delay. Impulse response describes the output of the filter when an impulse signal that is zero everywhere except at one point is applied to its input. It illustrates how the filter responds to sudden changes or impulse in the input signal. Step response describes the output of the filter when a step function signal that changes abruptly from one constant value to another is applied to its input. It shows how filter react to sudden changes in the input level. Signal level transient response. It describes the behavior of filter as it transitions from one state to another in response of sudden change in the input signal. It provides insight into the filter settling time and overshoot. And delay represent the time it takes for filter to respond to changes in the input signal. It indicates the amount of time by which the output signal is delayed compared to the input. Now the second last question which we have to tell about the frequencies main parameters for filter, which are cutoff frequency, stop band frequency, pass band, ripple, transition, bandwidth, and roll off rate. Cutoff frequency at which the filter's response is attenuated by a certain amount. Stop band frequency range where the filter's attenuation is high, typically in band pass and band stop filters. Pass band ripple if non-ideal filter like Chebyshev and elliptic filters. This parameter represent the maximum allowable deviation from the ideal response in the pass band. Transition bandwidth, the frequency range between the cutoff frequency where the filter response transition from the pass band and the stop band. Role of rate. Describe how quickly the filter attenuates frequency outside the passband or stop band, usually expressed in decibel per octave or decade. Now the last question which we have to discuss the role of low pass filter for filtering design. So low pass filters are essential in filtering for several reasons. They are used for noise reduction, anti-aliasing, pre-processing, bandwidth limiting, spectral analysis, and frequency response equalization. So the noise reduction in which they remove the high frequency noise from signal, improving the signal to noise ratio. Anti-aliasing before digitizing analog signal, low pass filter prevent aliasing by removing high frequency components. Pre-processing, they prepare signal for further processing, preventing distortion in subsequent stages. Bandwidth limiting, low pass filter restrict the bandwidth of the signal in the communication system, reducing interference. Second last one, spectral analysis. They isolate specific frequency bands for accurate analysis. And the last one, frequency response equalization. Low pass filters shape frequency response to compensate for system losses or distortions. And these are the low pass filter basic benefit that are required for a communication system, and it is very useful for communication systems. Uh, So now we will move towards our MATLAB task in the first task we have to take a signal that is given to us and we have to apply a 3 tab 11 tab and 25 tab on the signal. So here you can see that I clearly take the signals as zeros 1 and 61 and the signal which is given to us in the question, and as soon as it is also given to us we take the append as given in the question 3, 11 and 25. We apply for loop and after that we apply the moving average filter and subplot them, and we use hold on and then plot the y command and apply legend and title to it. So when we run this program, so as you can see, so it is clearly showing the time domain differences between 3, 11 and 25 tab filters. So now we will move towards our next task in which we have to apply in part A we have to design a low pass filter with tab length and plot the frequencies. So we take the plan we have as we done in the previous program, we apply for loop and we run the program according to it by ones, one tab length and divided by tab length. Similar, and then we will plot the frequency tab the frequency responses that occurred due to tab length, and then we will move towards the part B in which we have to design a low pass filter with 3 tab and frequency of 800 and sampling rate of 8000. So we take cutoff frequency 800, sampling 8000, normalized cutoff frequency divided sampling rate by 2, and then we apply the formula and apply filter using fill function. So we will plot in the part C we will have to plot the magnitude response. So we have the omegas given in the question. So we use them and then use the formula and then plot them. So when we run this program, as you can see, they are showing very different graphs of this is a part C graph of the magnitude response which we have to plot and which we have given omega. So this is the graph that is plotted. But and now the frequency responding that we have to calculate on the basis of the table length. So it is of 101, it's of 51 and it's 17 and it's 7. So this is the part A of task number 2, and now in the part B similarly we have to do the same thing. We have given the function, now we have to apply tab length on them and plot their responses. So we will run this program, and as you can see in time domain and frequency domain. So as you can see, I use the formulas there to plot them. So for that you can see that 101 tab filter time domain and frequency domain. Now 51 tab filter in time domain and frequency domain. 17 tab filter in time domain and frequency domain. And 7 tab filter in time domain and frequency domain. It is clearly showing the difference between them. Now we will move towards the task number 3. In similarly, in which we have to create first of all in the previous task we are taking time domain also and checking the difference of tab length in them. But in this program we will only check the difference in frequency domain. For that we have given the for frequency time the time limit between the frequency and three functions, and we have to plot them. So their tab length is given 17.51.101, and the frequencies which we have given in the question like lower cutoff for to higher, upper cutoff, normalized cutoff for. So by using these all the formulas and everything, we will in part B calculate filter coefficient for 5 tab. And similarly, like in the previous one, we have the plot for the 3 tabs. So after all this, when we run this program, as you can see, there are multiple graphs are showing, and I will do that. This is a frequency response of 5 tab FIR bandpass filter, which we have to calculate. And now its frequency response of 101 tab FIR filter. This is frequency response for 51 FIR bandpass filter. This is for 17 tab FIR bandpass filter, and this is for 7 tab FIR bandpass filter. This is a part A of task number 3, and now we will move towards the task number 4, in which similarly we are provided with the frequency and signals and tab length. By using fill function, we apply the filter on it, and then FIA band pass filter by using the fill function. Then we apply the filter on it, and then we subplot the signals of original signal and that signal FIA band pass signal in frequency domain. So when we run it, as you can see that this is time domain 7 tab FIR bandpass filter, and this is frequency domain, and similarly it is for 101 FIR time domain and frequency domain, and this is for 51 time domain and frequency domain, and this is for 17 tab FIR bandpass filter for time domain and frequency domain. And this is all for tab number 8. Thank you so much.